right. So, okay, everybody. Thanks for logging in today. Today is September 21st. This is our third quarter ROS-Industrial community meeting. We'll touch a lot on consortium activities, right? So it's consortiums in the title today, but it's open to the public. So we'd like to thank all of you for attending and all of you those watching later. But anyways, this is meant to be sort of like a chance to get some voice from the community on different initiatives and things we have going on, and to provide additional feedback. So that's why we get together at least once a quarter. So thanks. Anyway, like I said, I'm welcoming y'all. About to kind of start on kind of what we've been working on here in Americas, right? So if you made the last developers meeting, I think 2 months ago now, what's going on in Europe? Obviously, the European ROS-Industrial team also had their annual conference in Bordeaux in July. So that was a really great cross-section of kind of some of the things they were working on. I believe those videos are up. If they aren't up, they'll be up very soon. I'm pretty sure they are up. I was just over on the ROS-I YouTube channel. Anyways, so today, like I said, I think before the recording was going, it'd be mostly my voice on the consortium update side. Even though we have a couple things going on, we may have some of our technical team members that can speak specifically about some of these activities on the phone. They just aren't able to present. So bear with me. I'm kind of covering a few bases today just because of scheduling conflicts. Anyways, Pablo's here today from eProsima to talk a little bit about what's going on with fast DDS and micro-ROS. Obviously, some of you may recall, Yaskawa announced their driver at the ROS-Industrial Consortium annual meeting when it went live. They presented on it at the prior year's ROS-Industrial conference in Stuttgart. It's now alive and actually has broader support now. It supports DX200, works all the way up through Humble for sure. I don't know about Iron yet, and even backwards to Foxy, and of course a lot of now good coverage across their development or their controller platforms. And it leverages micro-ROS, right? So it seems prudent to have eProsima, since they are the providers of micro-ROS, kind of update this audience. So they've been engaged with a lot of the ROS-Industrial European community. But this is I think the first time they're presenting to an America's audience. So thanks, Pablo, for coming. All right. So anyways, just as a refresher for those who don't know, kind of what we're trying to do with ROS-Industrial, right? So we largely focus on basically creating open source resources to enable access from ROS to industrial relevant hardware and enable industrial applications. So obviously there's some level of software engineering all the way down through and developing utilization or enabling even operators to be somewhat effective and dangerous, right, if you will. Dangerous not in like the executing of their job or working with robots, but able to enable the robots or guide the robots into doing high mix tasks. We also in our day-to-day jobs use these tools too, right? So we're not just open sourcing stuff. You know, another role we do and why a number of our team members couldn't be here today is we're doing projects leveraging these tools as well. And we do our best to make contributions back to them. One I'll touch on later is a great example of Scan and Plan Workshop, which has had a number of commits lately that in parallel with an active project, right? And so that's not just the consortium dues help maintain these, but obviously where we can and where permitted, we try to make them better in the work that we do as well. And then of course, obviously, there's this notion of how the tools work, right? So very recently, there's been some comments on a couple different repositories. I'll highlight one in particular, a conversation that was on industrial core, and also highlight the road mapping discussion on Nether, which we have highlighted, I think, in the ROS-I developer meeting, but not necessarily this community. But then obviously I'll try to touch on a little bit kind of where we are today relative to where we want to be. So, you know, one thing that we did recently in May is we got together and talked a little bit more about the roadmap, right? So one of the things that came up is a little bit around better supporting ROS2 and then how people can either like, you know, what are some resources for them to help in an industrial deployment context, ROS2, but also like say something around like drivers, right? In industrial core, and I'll touch on industrial core specifically later what is the status of driver support for manipulators, right? That's over here on the right-hand side. How are we doing that? And one of those big things is this notion of OEM outreach. And we'll talk a little bit about that. We recently at the European meeting, it sort of became pseudo-officially announced that KUKA now has a ROS control-based driver for ROS2. So that's a really exciting development. Again, we're typically somewhat aware. We have friends at all the manipulator companies, and we are advocating for them to support interfaces in a couple of different ways. ROS2 is a little bit different, right? I'm going to touch on this again later when we talk about the industrial driver specification, but we're taking a little bit different stance here, and ROS2 is going to enable a little bit more flexible way for OEMs to design their drivers. But that's actually been a big push recently. Anyway, so yeah. So speaking of the drivers and manipulators, right? So we've gotten a lot of inquiries over the past, I would say, year and a half, in particular about porting of industrial core. For those who don't know, and I do have a graphic that kind of shows the before and after. Industrial core basically implemented a message strategy that enabled common low-level protocols that communicated the joint states of the robot to come back into ROS, be translated into something ROS understands, and vice versa. That protocol that was implemented called Simple Message was a really nice way to kind of show what can be done with an industrial manipulator interacting with the ROS ecosystem. However, it had some limitations. There was actually a big, and there's a blog post we can go back to about some of the security risks of that approach, being where it resides and how it actually interacts with the industrial robots. There were some risks, and it's no longer it was no longer viable to really version it, particularly as industrial robots improved. Right now that more and more OEMs are offering their own interfaces, right? This notion of external motion interface, many of you may have heard of ABB. External guided motion, for instance. Yaskawa has similar tools. FANUC now has what they call RMI, which superseded their lower level interface, external motion interface. So now a lot of these robots have very nice external motion interfaces. So using something like Simple Message and industrial core doesn't really make as much sense. It doesn't take advantage of these advances and allowing the OEMs to create interfaces to take advantage of their latest offerings. So one thing is we've been working hard. We want the OEMs to own, right? So if you remember, for those who've been around a long time ago, there was a UR driver, and there was a very famous issue created calling it the worst piece of software ever designed or something like that, right? It got a lot of chuckles, but it really highlighted the problem we had at the time. We could implement a driver, but because it was just taking advantage of some of the tools available, we really struggled with sustaining those, because what would happen is in UR's case, they would make an update to the firmware and the driver would fail. It would no longer be valid. And that is actually that ends up coming back on the program. It comes back on the open source project, seeming like that we don't know what we're doing, right? So the whole goal was hey, it would be really great. And now, because OEMs are creating so many external motion interfaces, this notion of an extra ROS component, if you will, is now such a smaller lift. And there's a number of different models. I highlight two here on the screen that have both been successful. Now we have a couple other examples where UR actually contracts out, if you will, the support of their ROS-facing component, but then they support an action client library that supports the lower level interaction behind, so they can make firmware updates and the functionality still persists, and it's based on ROS2 control. Yaskawa took a slightly different approach. You're going to hear a little bit more about micro-ROS later. Basically, DDS is a specification for distributed data services, and it comes with all these guidelines and a framework to implement deterministic and high-performance communications in systems in a very distributed way. Well, one part, a subset of DDS is this XRC, or an extreme resource constrained implementation, and that's basically what micro-ROS enables, right? So Yaskawa had the idea hey, I can compile this really low bandwidth version, right, on my controller, right, because it's small enough. And so this was the first instance of a ROS node actually running on an industrial robot controller. So we're all very excited about that, and it's just another example of how OEMs now have some freedom, and they're more willing to, because it enables them to showcase their equipment in the way they want, yet can participate in the ROS ecosystem. That's the very long-winded version of that, right? So anyways, this is sort of how it was back in the day. We had to create this ROS interface layer. This is the simple message, the low-level protocol I mentioned. And then the vendors would have to provide some translation, if you will. So there would have to be something that the robot controller enabled. Obviously, now in a ROS-2, you can see I've kind of exploded this out because, hey, there could be another way to create a ROS-2 driver, right? And we mentioned micro-ROS, and in the case of Yaskawa, it's a tool they have called Moto-ROS, part of their Moto Plus SDK as an option. So I just called it OEM Tools, and it interacts with the RMW in this case, right? Obviously, the way it exists today, micro-ROS is somewhat dependent on fast-DDS, but they do interact with Connext. ROS-2 control, obviously, you'd want to probably have your RMW match. And of course, you can still do this bridge if you really want to go that way and use the legacy approach. That still works, and we have a number of users doing that. Depending on how we're actually interacting the manipulator with the ROS application, we do that as well. So anyways, but this is sort of the new snapshot, which I grabbed. We look forward to doing a little bit of a versioning of this documentation and creating a driver specification around sort of some of these better practices. There isn't, maybe these are the two best approaches, but ideally, right, to give some guidance to OEMs to be like, hey, this is how you should do it. And so we're taking that into consideration and hope to have a version of formerly the Robot Industrial Driver Specification, which is under the ROS-Industrial Wiki, updated in the next few months. Right, what do you know? So we're currently right now in the planning phase and providing pathways for OEMs to build out their own drivers. There was debate about a reference implementation, TBD. I do want to talk a little bit about the roadmaps to ROS-I repositories. Again, I've highlighted Nether before. If you go under to ROS-Industrial over on GitHub, Nether is the toolpath planning framework. There's a discussion tab across the part, and this refactor is up there, right? So we're creating more and more of these to basically get feedback from the community for those who are really interested in using these tools for kind of what they would like to see. Right, so it's under discussion because, hey, it'd be great to hear some feedback. We have gotten pointed questions in other community meetings about what is the roadmap or the design goals, right? So we have obviously this higher level ROS-I roadmap, certain things we want to do. We talked about the notion of kind of like standard applications. We've made some really great headway there with Scan and Plan Workshop as an example application, but obviously these underlying tools need to come along as well. So there's actually a nice document out here on Nether in particular. Feel free to check that out. It's becoming sort of a template. Relative to bigger projects like Tesseract, if Tesseract is something you've been monitoring, we are looking at kicking off the developer meeting, if you will, for Tesseract. We had a big discussion at FabTech in Chicago with a couple other stakeholders about bringing those back to full, like, so we can actually have a little bit more of a broader community consensus on how to manage Tesseract. Right? So stay tuned for that. I've mentioned this before. One of the ways that we're trying to manage ROS-1 and ROS-2, and this is important, right? And this is also why we have like kind of left things as they stand in ROS-1, right? Because we've tried to make a lot of the capabilities, so to speak, ROS agnostic. It gives us the flexibility to go back and forth between ROS-1 and ROS-2 and service a number of users who don't want to actually leverage ROS, right? So for instance, we've been doing a lot of work in space. It's been taking advantage of Drake. So we're not necessarily using a lot of the ROS components anyhow, right? So this has really been beneficial, and it's still the path forward where we can. Some of you may have noticed Reach, which I'll be talking a little bit again in a little bit as far as an update for something going on in Reach. Now actually comes, there's Reach Core, and then you have a wrapper for ROS-1 and ROS-2. So where possible, we are still trying to maintain that capability of being ROS, independent of ROS as best as possible. So I touched on Scan and Plan Workshop. It's actually an older slide, but I just wanted to point out this part of the vision, and something we're working to is providing applications. So this is Tyler and Michael. Thanks, guys. So basically, right now, there's been a lot of commits. If you haven't been tracking, there's been lots of additions to Scan and Plan Workshop. We also now are using Scan and Plan Workshop, even though we're not putting on full day workshops, teaching you to build Scan and Plan applications. We are still hopeful to do that. We're still trying to find the right venue and the way to get it done. But we are leveraging, for instance, the motion planning side as an advanced topic. And Tyler, who's on the line, helped get that going and actually put that class on in July. So if you have a question, there's this recording of the developers meeting that goes over and steps you through Scan and Plan. So there's been obviously Scan and Plan Workshop has gone through some changes. And I'll touch a little bit more about some other content around Scan and Plan that'll be coming out soon. And then there's just a me of a video running it. You don't need to see that. It's out there. Anyway, so I want to touch on training. So we had 3 training events for 2023, February, July, and October. October is open. So if you're interested in making a ROS-I training event, you can check it out. You can go to rosi.org/events. I'm just going to put the actual website up here because I realize that hyperlink is not going to work through the screen. But I think we're going to probably just re-roll out the motion planning pipeline and tuning advanced topic. But if there's any other questions or inquiries around training, don't hesitate to reach out. Obviously, we're always looking for additional training topics and workshops. And we're still working on the lab exercises for day 3 relative to ROS-2. And we've had this notion of bite-sized learning. We're still efforting, if you will, that initiative. So stay tuned. So we're really excited about Reach Workshop. So if you go over to roscon.ros.org, Michael Ripperger on October 18th, it might be the day before. The agenda's on the website. You don't need to hear me talk about it. But anyways, Michael will be putting a workshop on around Reach. Reach is a ROS-Industrial utility that enables basically what you see on the screen here, right? So for a given part position, a given manipulator base position, it can tell you which waypoints are most reachable, right? And as they get more problematic, either the color changes or you're getting close to a singularity, you'll notice the kind of dark void here in the middle of the hot zone, right? And we have a hot zone, we have a green zone, and you have this sort of void in the middle, and that's because the robot gets sort of bound up on itself, right? So it's a really great visual tool for designing your systems, or how do you orient parts. It can run in a number of different ways to give you visual indicators for how your system and part relative to each other are going to enable you to execute the work you want to do. And so it's actually being incorporated into a really interesting painting project funded by the ARM Institute in collaboration with Ohio State, Northrop Grumman, and Robotics, which we're team members of as well. So it's really exciting to see this get pulled into bigger applications. So check out that workshop if you're going to New Orleans in October. We encourage you to check it out. I hear there's still space available. So if there's any interest in that, let us know. More on ROSCON, right? We will also ROS-I will be exhibiting, right? So if you end up coming to New Orleans, we'd love to see you stop by the booth. We'll be happy. We'll have technical folks there you can chat with. I believe the European team will be sending 2 people as well. So if you have questions or interested in driving synergies between the regions, we're interested in that too. So feel free to raise those sorts of topics. Asia Pacific will not have any team members, I believe, attending ROSCON, but we'll be monitoring it closely. Registration is still open, so feel free to check that out. And our friends at Picnic have organized a MoveItCon taking place the day before the main thing kicks off. So you can check that out here as well. So at the consortium level, right, like I said, these are some pictures from the recent annual meeting. We are still doing what we can to bring people together, right? So we're working now also trying to educate various industry partners. Obviously, welcome ASTM International, but obviously we're working with, let's just say, more on the floor, if you will, organizations as well to get voice of industry. The picture on the bottom right is actually a kind of a workshop, even though it was at our ROS-Industrial meeting, hosted by the Steel Founders Society, right? So you had some Foundry members, you had universities supporting Foundry technology, and then others, in the robotics community, let's hear what these foundries are having issues adopting technology, right? And there's a real desire to maintain the ability to generate and make castings in the US. What is the delta between the things we're working on and these needs and challenges in foundries? where foundries are, yeah, everyone is a lot size of one. It presents really unique challenges. The environment's pretty harsh. Real big opportunity there, right? So it was really great to have them put on like a little workshop session, get their technical folks to talk with, and roboticists, another roboticist across industry, right? So we have the robotics team from Caterpillar. Here's Lockheed Martin, right? We had Arm Institute's tech lead here, among others, right? So along with the Foundry members and developers. So it was really, really an interesting discussion. It was great to have them there. One last thing, and just like the general stuff I'm trying to share that we're working on is the update to the website. So if you go to ROS-I.org, it'll take you to this slightly antique looking website, right? Obviously it's almost vintage in a positive way at this point, but we are working on refreshing it, right? So this is sort of like a little sneak peek preview of kind of the look and feel we're going through. The goal is to tie together a little bit more of the resources, educational things, and the software, and really make it easy to navigate to those places. Because currently, as you may know, the website has no real tie. There is eventually a link that gets you to the GitHub repos, but it's not super intuitive. So ideally, moving forward, the website will be a little bit better resource to kind of help you navigate. You will still be able to say, we'll get a note if you submit a question or do something. All those other sorts of features will still exist and work. We'll continue to write blogs and try to get cool stories up there for you as well, let you know what's going on and updates. But ideally, it'll just be a little cleaner. So stay tuned for that. We're hoping to roll it out for ROSCON. I owe tons of written content, so I'm probably why it's behind. Anyways, I got a couple project updates, and then I'll get you over to Pablo soon. So normally this would be someone else, but it's fine. All right, so for those who don't know, we recently launched what we call the Focus Technical Project. Focus Technical Projects are where consortium members can kind of join forces to kind of solve a problem. Robotic blending has been a Focus Technical Project through 4 prior iterations. In the last iteration culminated in a demonstration at, I'm gonna see if my video will work again, culminated in, because I'll talk with my hands, culminated in a demonstration at a robotic integrator that was common for some of the members. And then it kind of went quiet, but obviously Scan and Plan was still getting deployed, both in industry and through other projects became open source. So some of you may have heard of the Collaborative Robotic Sanding Project. There's an open source implementation of that top level application over on GitHub as well. It's not in ROS-Industrial, but if you have questions about it and are curious about seeing it, it was in collaboration with the Arm Institute and Spirit Aerosystems. I can always forward you those links. It was actually one of the first full ROS2 applications on our done for industry. Anyway, so Scan and Plan kept going, but this is the first time we've relaunched a Focus Technical Project. Its backing is the champion was the Steel Founders Society of Americas. Their goal is to create a starting point framework for Foundry Scan and Plan systems with some other different modules and add-ons that are sort of unique to how the foundries envision leveraging automation. They call it job shop automation, right? Where operators are interacting with the robots in intuitive ways to drive high mix processing. And here's the other partners. And we have some in-kind partners like the Edison Welding Institute and Aris Technology as well contributing. And so anyways, so ideally there's this core framework. Now I mentioned a lot of commits to Scan and Plan Workshop. That's happening in parallel with this work. So those are the contributions back to the open source. There's also then going to be eventually a repo for all the implementations we did here at SWIRI. And that'll be open source per the guidelines of the Focus Technical Projects. So as I mentioned, intuitive agile automation, right? So they do a lot of different parts. You'll see some examples here. I've got a video. Ideally, right, they want to avoid the teach pendant programming. I think obviously in the ROS land, right, I don't think half our team ever touches the teach pendant. But they are reduced the reliance on this part-specific tooling, so not a ton of work holding that drives a lot of cost and complexity, and they want it to work. So that is these environments sometimes can be really, really difficult. So we're extending this FTP. It's a Milestone 5, and it's a milestone. The milestone is it actually works in this real foundry. So we're going and dropping a robot in a foundry and showing it off. And so we look forward to here in about hopefully 3 to 4 weeks, actually doing the demonstration at the Foundry, which is the SFSA partner site. So this is like our quad chart we use for focused technical projects for amongst collaborators. And so we're very excited to actually get this going and showing it off. And this is some of the work to date. One of the ways they want operators to be able to interact with the parts is draw simple boundaries. In some cases, actually, Iowa State University, the university collaborator, has an implementation where they have this area you want to basically finish, which would be this circle you see on the inside here. And then you want to match where you're grinding to what they call the interpolation region, which is the kind of secondary circle. This notion of interpolation, like doing work, what we got to remove, and then interpolating is a way to generate a smooth contour surface over it, right? So we've been evaluating different ways to manage approaches and departures, how we apply these toolpaths, how do we make assumptions about interpolation. Obviously, when the part's nice and flat, like the sample you see here, that's not so hard, but it gets trickier as we get into more complex contours. So we've been doing some work on segmentation. You'll see some potential additional workup on that here as the program progresses. So stay tuned. We could probably have a couple blog posts coming out on learnings from this. Our team member recently, this is the to be deployed system at the Foundry. So a specific system is being built and delivered to a Foundry as part of this program. And the Foundry will basically eventually take ownership of it. But this actually steps you through the UI. There's the particular casting of interest. You'll note there are obviously the drawn boundaries are already on there. You can see here we're working with what we call a mesh modifier. So because we're working with colorized meshes as part of industrial reconstruction, which there's a blog post out there about that, and of course the repo, but the colorized mesh, we take advantage of the colorized mesh to actually then do the segmentation, right? So here you can see the approaches and departures and the raster paths applied within the tooling. We do then generate motion plans. And here we're actually working with grinding stones, which is sort of new. For those who've been following Scan and Plan, it's typically been discs, which offer an advantage that they have a little bit more compliance. So doing a little bit of tuning and having to adjust how we manage approaches and departures for stones has been a little bit of a learning exercise, but that's been very interesting. So that's the progress there. Michael was mentioning he might call in from the road, but it looks like he's not here. So I'll give a little bit of an update on SWORD. So for those who aren't aware, SWORD is a plugin, if you will, to FreeCAD that enables basically menu-driven from a CAD environment setup of ROS applications. So obviously, historically, we talk about offline planning products. We have our vendor-specific products, which would be your sort of OEM-based or things like RoboDK. But like, you're sort of limited to teach-pendant style programming. On the ROS side, we can do all kinds of really cool stuff. We can do optimization, toolpaths, all this collision avoidance stuff. But it's not easy to use, right? So a couple years ago, we had a panel on a ROS-I Industrial annual meeting, and they were like, we just want an easy button, right? And then so we started down the path of building sort of this kind of tool to enable you to configure systems graphically in Ignition. And we started circulating that around. They're like, well, you're making me leave the CAD environment. That's a problem. Like, why don't we just stay in CAD? And so that's been the maturation, right? So there are some tools that offer this slice, but there's really nothing here that allows you to like really play around with ROS capability from a CAD seat. So that's what we're doing. That's SWORD, right? So we've been there's been a lot of movement in developing ease of use tools, right? So obviously Ready Robotics would be an example of a robotics startup. We had Real-Time Robotics. There's a couple others that are doing some really interesting work in the startup side. Move It Studio by Picnic it has been very highly featured. It's also seeking to create like some ease of use, like anyone can just do this. And obviously some of you may have caught the announcement of Flow State by Intrinsic. SWORD's a little different as it's very industrial focused and we're trying to stay in the CAD environment, right? And like allow you to mess with things like optimization and set up your own robots if you want to, right? So it's got a slightly different look and feel. It leverages FreeCAD, which is already free and open source. So it's a slightly different approach. So this is a screenshot of kind of what the UI looks like within FreeCAD. The idea here is like, yeah, we can give you access to some of these advanced robotics capabilities right from the CAD environment. And that's what we're going for, right? The integration with ROS is sort of, if you will, loose, right? So because a lot of our core capabilities are ROS agnostic, you can go a ROS direction or not, right? As you set up your application on a real robot. So that's sort of handy. So, but the key is our audience has always been manufacturing engineers, like, right? So people know their processes and they know where they want to put their process. So bridging together the computer science world of ROS and this manufacturing engineering world has been sort of a journey. And that's the audience we're seeking to address. So the sorts of things that we can do today are around environment creation, motion configuration, right? This notion of motion group definition, solver configuration, and the notion of motion planning, right? So, and you can do some configuration and pipeline configuration. What that means is like how we handle, like, say, bouncing between, you know, setting up your optimization. What are we seeding optimization with? If an optimization doesn't really go like you want, what does it kick over to? And then, of course, just some real, if you will, CAD-like tools, right? So we can export URDF, SRDF, or robot native programs, right? So we do that a lot already, right? So we post-process those ROS messages and we FTP robot native programs. We can do that too. So this is sort of kind of where it sits today. We are offering trial seats. So if your organization is interested in playing with Sword, let us know. We are open to feedback and letting you play with it. And then, like, yeah, let us know what works, what doesn't. I was really, really happy to hear Dennis Stogel over at the ROS-I meeting in Europe in Bordeaux mentioned Sword and said, like, hey, it really helped us out. It's a really neat tool. So it was really cool to get that sort of like unprompted endorsement. Our staff is also then taking advantage of using it as well. And so it's really helped us in our workflow. So we're not just developers, we're users. Built on open source, right? It's a learning tool, and it's a great entry point to getting into this sort of advanced robotics capability, and that's what we're trying to do. We're still in the air on like how to really like make this available as a thing that you go get. So right now it's kind of like by email and asking us, and we're trying to figure out how to get it out there in the world, and then how do we support it, right? So at some point it might have some nominal subscription fee to keep it alive and well and working really well. So we're not necessarily, it's not necessarily a ROS-I explicit tool in that regard. It's a little bit like following the model of Move It Studio, right? That Picnic's offered, but much more slanted towards the industrial engineering community. Anyways, if you have questions, feel free to reach out to Michael, or you can always just contact me. I'm always happy to be the threat to choke on any of these ROS-Industrial adjacent topics. So that's Sword. Any questions on Sword? We have open forum at the end too, so you can ask me all kinds of tough questions. Great. Without further ado, and I appreciate everyone's patience, I'd like to introduce Pablo Garrido Sanchez. He's with eProsima. He's going to be talking a little bit about ROS-2 integration on embedded devices. Pablo, looks like you got your lighting worked out. That's great. Thanks for joining us today. I will stop sharing and I can hand. I assume you have content to share, correct?
Okay. Perfect. So let me share my screen. Can you see it?
Yeah, it looks good.
Perfect. So thank you very much for the introduction, Matthew. I'm Pablo Garrido. I'm part of the engineering team here at eProsima. For those of you that do not know us, we are the company behind FastDDS. That is one of the most used open source implementation of DDS, and also is the default middleware of ROS-2 in almost all the distros. This is an open source product, and we have been working on that for many, many years, a very mature DDS product. But we also have some kind of interest, and this is the point of the talk that I want to share today, that we are evolving some of our technology to be integrated in embedded systems. We have had a micro XRCE-DDS that is an implementation of another OMG standard, that is DDS XRCE. XRCE stands for Extreme Resource Constraint. environments. And this is a middleware that targets devices with very, very low capacity and memory. This has been our traditional solution for embedded systems, but leveraging the knowledge and the know-how that we have on both worlds in embedded systems and also in DDS, we have been the last 2 years developing a new product that targets both safety, functional safety, and embedded development. And this is SafeDDS. This is the new product that I want to present here today. But we are also we are gonna also talk about XRCE-DDS and of course micros. First of all, I want to make a quick introduction, reflection about robots and how are they made. Robots are made of sensors and actuators. Those sensors and actuators are controlled by low-level interfaces, UART, SPIs, A2C, and those kind of low-level interfaces and protocols. And the data that we retrieve from sensors and the command that we send to actuator are controlled normally by real-time control loops. And microcontrollers provide these low-level interfaces and also the hard real-time capabilities that are required to the control loops. But the point here is that robotic engineers mostly use ROS-2, and ROS-2 only runs on general-purpose CPUs. And those general-purpose CPUs does not have low-level interfaces nor have real-time capabilities. So this is the situation that we have here. We have a bunch of silicon vendors that are creating amazing devices and amazing microcontrollers, for example, ST or NXP or Texas Instruments or even Renesas. And we have a lot of frameworks, real-time operative systems that allows us to write high-quality embedded application. For example, we have the traditional FreeRTOS or even the Zephyr project that is a new RTOS from the Linux Foundation. We even have Arduino for quick prototyping. We already know that. We have a huge ecosystem on the embedded side, and on the other side we have ROS-2. We know it. We have amazing tools like NAV2 for controlling AMRs and planning. We have Movit for kinematics and planning in robotic arms and visualization tools like Arbis or simulation tools like ASIVO, but we do not have normally in ROS-2, we did not have a connection between those two worlds. The point here and why are we talking about ROS-2 embedded is that we found interesting to have ROS-2 nodes and ROS-2 code running close to the metal in order to have direct control over those low-level sensor and actuators that forms the robots. And also, it's very important to reuse this philosophy that have ROS-2 of reusing available packages and defining common interfaces to interact between different parts in a system. The point here is that the embedded world have a lot of problems. We have a lot of vendors, lack of standardizations, a lot of tool chains, frameworks, IDEs that are not compatible between them. We have devices that are very limited on resources, normally below 500 kilobytes of RAM. Maybe we have lack of portability. Sometimes you don't have C++ support or even standard libraries or even not a complete libc. And then they are slow. They have low bandwidth interfaces. Normally CAN buses, UART, SPIs, they are not comparable to Ethernet interfaces. So this is why we at eProsima 5 years ago started a European-founded project with a consortium to create micro-ROS. Micro-ROS is a port of the ROS-2 stack that targets embedded devices. We provide a set of tools and functionalities that allows users to build and use most of the packages that ROS-2 offers in embedded environments, in microcontrollers with FreeRTOS, in RTOSs, or even in Arduino. And micro-ROS is a set of ROS-2 packages that can be cross-compiled, that are optimized for embedded environments, and also a set of ROS-2 packages that has been ported to embedded devices. Micro-ROS has the same distribution system as ROS-2, so now we support Humble, Iron, and Rolling. and it offers the very same interfaces that ROS-II does. For example, you have access to publishers and subscribers, services, actions, or even parameters. You can see here in bottom right corner the stack of micros. As you can see, we reuse the core packages of ROS, but we change the middleware. In the left side, you can see that FastDDS is the middleware for ROS-II, but in micro-ROS, we use micro XRCE-DDS client. Micro XRCE-DDS client, as I have mentioned at the beginning, is a lightweight implementation of the XRCE-DDS standard, and it needs an agent, a micro-ROS agent, that communicates with the microcontrollers and acts in the DDS data space, and of course in the ROS-II data space. As you can see here, by means of changing the middleware, we can run the whole ROS-II stack on any kind of RTOS, or even in bare metal without environments with no OS or RTOS, and in any kind of microcontroller architecture, normally in ARM Cortex-M or RISC-V or Stenza processors. Also, we provide a new ROS client library that exposes an API in C99 that targets real-time. This RCLC, the ROS client library for C language, exposes the very same functionality as the normal RCL-CPP or RCL-PI, but targeting real-time and C99. As I have mentioned, the very core of micro-ROS is the middleware Micro XRCE-DDS. Micro XRCE-DDS is a library that provides two different libraries, one for the embedded side and another for the DDS side. The embedded libraries is a super small library that targets devices with very, very low resources written in C99, and is super easy to port and can run in a couple of kilobytes of RAM. And on the other side, we have an agent that is a bridge between this XRCE-DDS world and the DDS world. The client connects to the agent using any kind of transport, UDP, serial ports, USB, CAN-FD, whatever transport layer that is able to send packages. And the agent acts on behalf of the client in the DDS world, in the DDS and also in the ROS-II world. It is DDS compatible as far as it exposes most of the DDS functionality and QoSs, but with an embedded friendly API. But as you can see here, this is a broker architecture. Multiple clients connects to a single agent or multiple agents, and this agent writes and reads from the DDS world. But we have a single point of failure here in the agent. This is the traditional approach of the embedded DDS. But we have been 5 years developing micros, and we have some use cases and successful use cases. Here you can see the Ircus AMR from Kappa Robotics, and they use internally, of course, they have a big computer inside the robot, but they use micro-ROS to communicate this big computer with ROS-II with the low-level controllers for controlling, for example, the wheels, the motors, the brakes, and they can have two parts inside of the very same robot, one for planning, moving, and high level, and the other for controlling low-level interfaces and motors in this case. And there is where we can find micro-ROS. In the example of guarding is the very same approach. Inside this camera, they have micros for controlling movements of the camera, the motors, and also for handling the interfaces of the actual camera, the focus, the lights, and all the things that need to be handled at real time. And finally, we have Renesas, that is a silicon vendor that have multiple families of microcontrollers, and they have choose, they are in fact our partners, and they have choose micros as the default solution for integrating ROS-II in their low-level microcontrollers. They have we have ports for this new Renesas RA family that are mostly Cortex-M microcontrollers, and they have full support of micro-ROS. But the point of this talk is also about the new generation of embedded DDS solutions and the new generation of embedded devices. The embedded silicon industry have evolved a lot in the last 5 years. For example, nowadays, most of the MCUs that we can see out there are based on ARM Cortex-M or RISC-V architecture. They are almost becoming de facto standard. And that means that now we have very powerful and open source compilers and toolchains for working with those architecture. Also, they have increased their resources. Normally, now it's not weird to find a microcontroller that have almost 2 megabytes of RAM memory. And also they have evolved the peripherals. Now we have more powerful communication interfaces in microcontrollers, and it's common to find 10, 100 megabyte per second Ethernet interfaces that allows working with advanced network libraries. So us here at the Prosima, we make DDS middleware, we make embedded DDS middleware and embedded ROS-I solutions. So we found possible to create DDS implementations that can fit this new generation of microcontrollers. And we found that it's possible to create brokerless communication middleware that allows MCU to be first-class citizens in the ROS-I and DDS data spaces. We also found that it's possible to implement the complex behaviors of communication protocols such as DDS, all the QoSs, all the fine-tuned configuration that you can have with DDS in those new generation microcontrollers. And of course, we found that it's possible to run more complex ROS packages due to the bigger computational power that we have in this new generation. And this is why we have been working the last 2 years in SafeDDS. SafeDDS is a safety-certified DDS compliant middleware library that targets a high real-time safety critical system and mid-low range MCUs, CPUs, and also ECUs. ECUs, the reason for targeting ECUs is that SafeDDS mostly target the functional safety standard for automotive industry, that is the ISO 26262. But it easy to port to other kind of functional safety standard for industry or even medical or other functional safety. So SafeDDS is the latest DDS product at the Prosima. It's a DDS implementation written from scratch, thinking on the embedded targets and also on the more powerful targets, written following modern guidelines, but a strict procedure. For example, we follow AutoSAR or MISR C++, and the whole library is written in C++14. It has a very, very, very low resource usage, so this allows us to work with SafeDDS in the very same microcontrollers that now micro-ROS support, but now having a full compatible DDS API and a direct communication with fast DDS and other DDS vendors. In general, that means that we have a full-fledged DDS implementation inside the microcontroller communicating through Ethernet with DDS or ROS-I, because ROS-I is wide compatible with DDS. In terms of performance, we have achieved the very same latency and throughput as fast DDS, but of course, we don't have the full DDS functionality. There are some advanced QoSs that you won't find, that are not implemented in SafeDDS because it is a lightweight library. And also, we provide certification artifacts for those use cases that need some kind of functional safety certification. As you can see here, I also have a link to the documentation later. It's a very modular architecture that is based on interfaces, on layers, very developer friendly. And every module of the SafeDDS stack can be tuned to fit the resources and the use case requirements. Finally, I have here a comparison between our DDS embedded products. As we can see, we have on the left side the new generation, and on the right side the available past generation with XRCE-DDS and micro-ROS. In general, the biggest change is that SafeDDS allows a direct DDS communication without the need of any broker. In the case of micro-ROS and XRCE-DDS, this broker allows us to have a very tiny libraries that does not consume too much resources. But as I mentioned previously, it is a single point of failure. There are different architectures and they fit on different use cases. Regarding the portability, micro-ROS and XRCE-DDS are highly portable. We have been working for 5 years on creating packages for supporting almost every RTOS available out there. We support Azure RTOS, Embed RTOS. We support the frameworks of ST from Renesas. We support Arduino, Platform IO, any kind of framework or tool that the community have requested. We have worked on providing some kind of support for micro-ROS. So nowadays, it's very easy to work with micro-ROS in any kind of environment. With respect to SafeDDS, we have been using this knowledge that we have from micro-ROS and XRCE-DDS, and we have created ports of SafeDDS for Linux, QNX, and also FreeRTOS. But we have been working also internally in making it work on bare metal environment. So we find that we can have a DDS implementation that runs on almost any kind of framework, toolchain, or RTOS. Regarding the interfaces, of course, DDS needs a network interface, so SafeDDS will work on top of Ethernet and Wi-Fi. But the point here is, as we have been trying to create a portable library, this Ethernet and Wi-Fi transport can be also be implemented using embedded network libraries, like for example, Lightweight IP or FreeRTOS plus TCP. In the case of micro-ROS and XRCE-DDS, we have examples and transports for running micro-ROS on top of UART port or CAN-FD port or even a USB CDC in any kind of wire or communication protocol that is able to send frames or packages. Another very interesting point of our embedded solution are the real-time capabilities. In both cases, in SafeDDS and also in XRCE-DDS, we target hard real-time. Our APIs are non-blocking, and even the memory management is very interesting because we managed to make the libraries zero heap memory free, or at least heap memory control, because the application developer has full control over where is the memory and how much memory is being used by both SafeDDS and XRCE-DDS. The numbers are here in the memory usage row. We can see that SafeDDS uses a very low memory, has a very low memory footprint. We can embed a DDS, a full-fledged DDS participant with one publisher and one subscriber in less than 64 kilobytes. And in the case of XRCE-DDS, the target are extremely low memory targets, because we can embed a participant and publisher and subscriber in less than 32 kilobytes. In both cases, this is a very low memory footprint in comparison with other DDS implementations that are available. And finally, the targets, the one that I have been mentioned, SafeDDS targets mid-low range MCUs with 100 kilobytes of RAM, CPUs, also the safety critical CPUs, or CPUs where some kind of certified for safety critical OS are running. Think about QNX, think about VxWorks, and also ECUs for the automotive sector. And in the case of XRCE-DDS and micro-ROS, almost any 32 kilobytes microcontroller can be used to work with micro-ROS and XRCE-DDS. So this is an overview of our embedded products here at eProsima. You have a very nice documentation of all of them for SafeDDS, for XRCE-DDS, and also the micro-ROS web page, where we have a bunch of tutorials and how-tos and how to get started, and explanations about how to work with ROS2 on the embedded world. So this was my presentation. Thank you very much. Let me know if you have any question.
Thanks, Pablo. We have time for questions. So if anyone wants to ask Pablo a question about micro-ROS or FastDDS, floor is open. All right, Pablo. It looks like you have everybody calm and
Okay,
understanding.
perfect. Thank you very much.
Well, thanks for taking the time, Pablo, and dialing in from Europe. So, does actually I have a question. Do you guys have anyone sitting in the Americas as of yet?
Yeah, we have some clients in America, in California, using micro-ROS, and we have a lot of users that are creating projects, and we know them uh, because we have a lot of community interactions in GitHub and Slack. And there are a lot of people out there working with micros, both for professional purposes and also for hobby purposes.
Oh, great. But but eProsima doesn't have any like staff in the States, correct?
No. We are all in Europe, in Spain.
Okay, that's fine. Awesome. Hi, May. Thanks for joining. If you have anything else to add, let us know.
Oh.
Well, great. Well, thanks again, Pablo, and thanks, Jaime, for educating. And again, this will be on our ROS-I YouTube channel and distributed to our members as well as a recording. So it'll live on. Obviously, Pablo, if you can share a PDF also of your talk, that would be super helpful.
Yeah, sure. We can share with you this slides. Right. Okay.
All right. So with that, that was our member share. We have some time for open forum. So if there's anyone in the audience that wants to raise a specific kind of question and or topic around ROS-Industrial, the consortium, the things we've been working on, this is your chance to do so. So let me have it. So we'll be hosting a training event in October. So if questions about training, that's fair game. Obviously, we'll be at ROSCON, and there's a developers meeting slated for October, which I think also might be hosted by us, in which case we'll zero in on a more technically oriented and deep dive on something, right? So stay tuned for that. I think the other thing maybe of interest would be, we'll obviously do another community meeting by end of year. We'll try to get some artifacts up for how this blending deployment. So this is the industrial system actually on the open forum picture here at Iowa State University. So we replicated 3 instances of this blending focused technical project. So kind of demonstrating that it can be pseudo equally replicated. They are running on a Kawasaki industrial arm. So stay tuned for communications about the outputs of that project. All right. All right. Well, if there's no other questions, comments, or concerns, we can adjourn. I do have to remind you that we have all of these resources for the community on the ROS-Industrial program side and project. So feel free to check those out. I think the ROSIN website is still functional. It's a really great resource for a bunch of interesting projects that were funded by the ROSIN initiative over in the EU. So feel free to check that out. So thanks. We look forward to hearing what we can be doing better and what we can be working on. So again, as always, don't hesitate to reach out to me. My contact information is here. We're very excited to continue supporting open source for industry and supporting the community and developing applications for industry. All right. Thanks, everybody.